When we think about torque, torque has a direction, right? Like if I apply a force on an object, and let's just pretend I have a meter stick here and it's balancing on a knife edge or it's rotating about the center. So if I apply a force on this side, upward, or I apply a force this side, downward, those two forces, let's just call them A and B, those two forces will both cause this to rotate counterclockwise, right? These two forces will cause this to move counterclockwise. If we changed and we had a force over here, we can call it force C pointing upward and a force D pointing downward. These two forces would cause this to rotate clockwise. All right, so when we talk about torque, then we can have positive torque and we have negative torque. So any force that causes a torque that the object would rotate in the counterclockwise direction, we consider that to be a positive torque. Now, anything that would cause it to rotate in a clockwise direction, we would consider that to be a negative torque. Now, you can think another way to do this in physics. We have a lot of right-hand rules. Those right-hand rules come into play when we have these vector cross products. So we take our right hand and we put our fingers in the direction of the radius. So if I were to be looking at the torque caused by force A, my radius is in this direction. So I put my fingers in the direction of the radius and I curl in the direction of the force. My thumb then will point either out, or if the force is downward, my thumb will point in. If your thumb points out or towards you, or if you have your hand on your piece of paper, it comes off the desk, the thumb pointing out, that gives you a positive torque. And then if your thumb points in or down into the board, it's a negative torque. Sometimes this is helpful with things that you're not quite sure how they would rotate, or you have multiple forces causing multiple torques on an object. Okay, so we talked about earlier the fact that unbalanced forces cause a change in motion, unbalanced torques cause a change in rotation. And so what exactly is the net torque? Well, we can find that just like we found the net force. So we can say the net torque is the sum of all of the torques. So if I were just to look at this guy here, I could say, okay, well, the sum of my torques will then equal the torque due to force A plus the torque due to force B plus the torque due to force C plus the torque due to force D. Now you can put them in there like this and just add. When I'm doing this, I like to right-hand rule or determine clockwise and counterclockwise as I'm doing the net torque so that I have my right positives and negatives in there. Okay, so torque A causes a clockwise rotation, so that will be positive. B will also be positive. C will thumb into the board, so that will cause a negative torque or a clockwise rotation, as will force D cause a clockwise rotation. So I'm just going to go ahead and erase my addition signs. So this is the net torque. Then you can just find the torque by taking the magnitude of the force times the distance from the lever arm, or from the axis of rotation. So in this, this would be the radius of A. This would be the radius of D, and then we have RB and RC. Now, in this case, all of these angles are 90 degrees, or all of these forces are actually already perpendicular to the lever arm, so we can just calculate our torques using F times R. So what are the units for torque? Well, if it's a force, then you have a unit of newtons times the radius, unit of meters. And so the unit for torque is given in newtons times meters. You might oftentimes see torque in the United States given the unit of foot-pounds. This is pretty common if you are changing a tire and you're tightening your lug nuts. And so the idea of a lug nut needs to be tightened to 100 foot-pounds, meaning if I had a wrench that was 1 foot long, it would need to be tightened to a tightness of me putting 100 pounds on the end of that wrench. So that's a really kind of easy way to gauge. So you don't want to always just stand on your wrench as you're tightening those lug nuts on your tires. If your wrench is really long, you want to put a little bit of weight on it. Or you can think, okay, well, how much do I weigh? And then you can calculate the distance from the axis of rotation, the distance from the nut you would want to be to put all of your weight to tighten that to the correct tightness.